back. So we have done a lot. We have put in our data, we've created scatter plots, we've calculated the regression equation, we've graphed with that, we found the residuals, which we put in L4, we looked at the histogram of the residuals, we calculated the average of X and Y as a point to make sure that the approximation of our line went through that point. And now the last thing that we want to do is we want to see, are any of these points an outlier? And the way that we check for outliers is we go back to the residuals. And I want to see, are any of these residuals greater than 2 standard deviations away from the line? Well, we haven't calculated that. We have not calculated the line's standard deviation yet. And you can calculate it by hand, but it is a bit tedious, and the calculator puts it out. So it's little s, and we're going to do it. All right, so we're going to go back to stats and in there and just make sure our x's are still in L1, our y's are still in L2, and our residuals are over here in L4. I'm going to get out of here. I'm going to go back to stats, and we went to calculate for the regression equation. To find the other stuff, we're going to go to test. So we're going to go over here to test. So I scrolled this way. You could scroll that way if you want. Now I'm going to scroll up because I know that my linear regression test and linear regression interval is the very end of this long list. So I'm just going to go up. There's ANOVA, and there's linear regression interval. We're not doing our interval. We're doing the linear regression t-test. So we're going to do the t-test. We'll hit enter. I need to know where my X list is. I need to know where my Y list is. That's exactly where I have them. X's are in L1, Y's are in L2. If you need to change that, your lists are down here. And now this seems interesting because you haven't learned about this yet. This part is for when we actually do the t-testing. We, as a class, are going to always test not equal to 0. So you can go ahead and highlight that. For the purposes of what we're trying to get out of the calculator right now, these 3 don't matter. They won't change what the value of our S is. If you wanted to, if you had skipped the first part and not done the actual linear regression and you just wanted to come in here, you can again store the regression equation. This is another place to store the regression equation. It is the exact same process as last time. You go to variable, you go over to Y variable, you choose where you're going to store it. See the other video on how to do that. I don't need to do it because I've already stored my regression equation. It's going to give me the exact same regression equation, and I'm just going to hit calculate. I said the exact same, but last time it made A be our slope and B be our y-intercept. It's the same values for your slope and your y-intercept. The y-intercept is still negative 4.18 about 77, and our slope is still 0.516 about. It's this next number that I'm curious about. For right now, don't worry about T, don't worry about P, don't worry about the degrees of freedom. We will talk about those in another time. Right now, we're curious about the other ones. These are for when we talk about the actual testing and what's going on for those. That's another video. You can scroll over to that if you need it. So right now, what I want is this S, and let's actually scroll down. Notice that because my diagnostic is on, it is giving me my Pearson correlation coefficient. So if you want, this is everything that we were getting out of our original linear regression when we just ran it to get the linear regression. The main reason I did it is because there's all that extra stuff that I don't want you to have to worry about right now. So this is what we're looking for is S, and S is 3.4678. That's probably good enough for the purposes of what we're doing. So what I'm hoping for is this is the furthest distance that I want any point. This is half of the furthest distance that I want any one point to be away from my line. So I need to know what is 2S. I'm going to find out 2 times 3.4678, hit enter. And so 2S looks like it's 6.9356. And this is the number I want to check. When I have a small data set, it's pretty easy to go in and say, is this, I know it's negative, but is 2.49 smaller than 6? Yes. 1.8? Yes. 1.6? Yes. 4 is really the biggest number here, so it's the one I need to worry for. But 4.5 is smaller than 6.9, and so this point, seemingly an outlier, is actually not an outlier. This lies within 2 standard deviations of the line. Again, looking at positive 3.005, is that within there? Same thing here. We can actually have the, sorry for the weird video jump right there. So what I'm trying to do is I'm trying to show myself mathematically that this number is bigger than all of these. Well, some of them are positive and some of them are negative. So what I'm really curious about is magnitude, is the actual size, right? I don't care that it's negative 2.49. I just care that 2.49 is smaller than 6. So I want the absolute value of all of these numbers. So what I'm going to do is I'm going to go into stats. I'm going to go back to lists. And I'm going to go here to list 5, and I want list 5 to be the absolute value of all of my residuals. So I'm up here in the part where it's like, hey, what do you want L5 to be? And I'm going to go use math, and then go over to number, and right there, ABS, that's the absolute value, we'll hit enter. And I want the absolute value, notice it has the nice, because my calculator is newer and has a fancy operating system, it actually shows the little lines for the absolute value. If you have an older one, it'll say ABS with a parenthesis around it. It's the same thing. And what do I want? I want the absolute value of L4. And we're just going to hit enter. And now I can see here's all my residuals as positive numbers. So you can do it either way. You can either have the residuals minus 2s, or you can do 2s minus the residuals. Just make sure that you pay attention to which way you subtract. I'm going to subtract the residuals from 2s. That way I know I'm looking for a negative number. If I have a negative number, it'll pop up and say, hey, this is an outlier, because I'm going to subtract L5 from what 2s is. So I'm going to go back over here up to L6, and I'm going to tell L6 to be 6.9356, or I could have done 3.4687 times 2. I could have done this up in here, and it wouldn't have changed it. And now I'm going to go minus, well, L5 is the absolute value, so L5, and we can hit enter. And I can see everything in here is a positive number, and because they're all positive, that means none of them are an outlier, because I did 2s minus the absolute value of the, so a negative number would insinuate that the residual is bigger, and a positive number would insinuate that 2s is bigger. We want to stay within the fences, right? These are like our fences, but for our line, so we want to stay within the fences. We want to have a positive number. A negative number would give us that it's an outlier. Okay, see more videos for more stuff.